welcome everybody. Welcome to our session, Building Enterprise-Grade Web Applications with Azure's Application Delivery Suite. Some of those things are new terms, so we'll talk a lot about kind of what does that mean to be enterprise-grade and what does the service sort of overall do and how do you kind of compose these things that we've provided to be able to create large-scale, global, regionally strong applications across your sort of application portfolio. More complicated now. So what is application delivery? Application delivery is fast and secure scaling of any web application that you're building. So we recommend global and regional resiliency, talk about how do you build it so that it's the most performant it can be, as well as how do you really scale those things up and down to be prepared for the unknown, for the type of traffic that you might receive at any one time. In particular, we're going to be talking about sort of more the components in the application delivery space, but because those aren't sort of atomic components, they don't work independently, is that we're going to talk a little bit more about the monitoring and protection space as well, because a lot of your apps, in order to be resilient and scalable, you'll have to include some of those. How do you monitor it globally? How do you have global optics? And how do you protect it with things like WAF? So to start, a couple new announcements in application delivery. We can press it one more. So some call outs, since we've talked about this all week, and you can see it online in our blog posts and things like that. In Traffic Manager DNS, long-standing ask to be able to hit IPv4 and IPv6 endpoints. The ability to do subnet routing, so if you have an ISP or some particular zone, like subnet that you want to have a different load balancing decision on, you can configure that, as well as the ability to support zone apex and alias records. For load balancer, long time ask in terms of being able to support a contiguous IP prefix, so that means that you can have all your VMs pull from the same /27, whatever particular block size you want to allocate, as well as the ability to support ACI or container instances in your VNet natively. From Application Gateway, huge performance improvements and auto-scaling ability in the App Gateway v2 platform, as well as integration with AKS, and then the ability to allocate a static VIP and deal with zone resiliency for Application Gateway. In Azure CDN, we now give you the option to be able to choose CDN providers. We are inherently a multi-CDN platform. We allowed you to pick providers from what used to be Akamai and Verizon only. We now added our internal service, which just went GA, so you can now pick from Akamai, Verizon, or Microsoft's CDN network to be able to deliver your content, or mix and match to your heart's content to be able to create a more resilient and globally distributed multi-CDN solution. And then finally, which we'll talk a bit about here as well, is a platform called Azure Front Door, which is a dynamic site acceleration and load balancing platform, which we put into preview just this week for folks to try out and start to really use that to scale up your site globally. All right. So what is application delivery? We really break it into 4 imperatives and 2 sort of scopes. So the 4 imperatives really are: you need to build robust, scalable, performant, and insightful applications. What does that mean? It really means a different thing to each individual application itself, of what do you consider imperative and at what scale for your application. Are you really looking for maximal robustness and the other things are less important? Are you looking for the ability to be robust while scaling? Are you looking for the ability to be able to scale while maintaining performance? The combination of those things seems to differ per application, but in general, we're looking at applications that really need to hit these marks, right? If you're moving to the cloud, you're doing it for one of these reasons. You're trying to scale out. You're trying to make your services more resilient. You're trying to work to make your services more distributed and more performant. And on top of that, you want insights into your application to understand how it's operating and how you're able to take that next step constantly to be able to improve the application over time. In terms of scopes, we really think about this regionally and globally. And if you look at Azure best practice, we talk about zonal resiliency in a given region, and we talk about multi-region resiliency for an application across the globe. If you're building an application, you should really think about how do you work across both the availability in a given region, as well as for both performance and reliability perspective to be able to distribute your application globally. So a note about our application delivery platform. We've talked about the 5 services here before in the slide about announcements, but we really have provided basically a suite of solutions and services that give you the ability to be able to compose and build up your application from the region all the way out to a global scope to be able to make it resilient, performant, scalable, and give you insights into how it's operating at each of those scopes so that you really can operate it at scale actionably. In this talk, we're going to talk only about these 4. We have another talk we did earlier this week about Azure CDN, but really we're talking about dynamic applications and how do you really build those high-scale global dynamic applications. So, load balancing in Azure. So we gave you, I feel like the last slide basically said I'm giving you a bag of tricks, go figure out what to do. But these things really do fit together. They work to create an application that is scoped from your internal solution as you're building your application in the VNet, to be able to stitch those components together to have your internal communication structured, all the way out to how do you build it at a region to be zonally resilient, to be scalable in a region, to have the right kind of agility in a region, to build your, you generally call them application stamps. And then beyond that, how do you scale out globally to be able to work across regions and to maximize performance, say like last mile performance, or how do you route to the closest region for each user independently. We've broken this down into 2 workflows for a little bit easier consumption. You can click it once more. So if you're building an HTTPS web application, we have a suite of tools in Front Door and Application Gateway that really give you not just sort of base level load balancing, but really give you more of an end-to-end platform of how to optimize and how to build your web application at scale. It gives you tools like WAF, it gives you tools like request routing, it gives you a lot more control and ability to move a lot of that business logic that you might have to build yourself into the actual load balancing and distributed platforms themselves. If you're not an HTTP-based application, and we'll talk a little bit about best practice at the end of the talk, but if you're not an HTTP application or you have different types of restrictions or you're working, say, in a hybrid environment, we have a pattern with Traffic Manager and our various load balancers that will get you that, layer 3, layer 4, or things that work with, say, dovetail with on-prem systems and things like that, through our what we consider our any protocol platform, which is basically Traffic Manager through standard load balancer and things like that down through your VNet. So, yeah, you can go for it. With that, I'm going to hand off to Amit, my colleague, who's going to talk about how do you really build for regional resiliency of your applications before you scale up globally.
Great. Hi everyone. Thanks for joining. My name is Amit Shrivastava. I am a program manager in Azure Networking along with Daniel. And today I'm going to talk mostly about the application gateway platform. So if you are aware of the journey of Azure, we started with the public load balancer, the layer 4 load balancer. And the overwhelming feedback we received from customers was that we require a load balancer which would do more at layer 7, specifically layer 7 SSL termination, a true round-robin distribution of HTTP requests, and cookie-based session affinity. So application gateway started with that. We launched in 2015, and since then we have added a ton of features. We are fully platform managed, so which gives you built-in scalability and high availability. You do not have to think about how do I keep these things running, what happens if Azure does any update, do they go down, and so on. You can scale them. So traditionally, it has been that customers choose a size and an instance count, and we take care of distributing them across fault and update domains. But I have some exciting new announcement in that space. You do not need to do that any longer. We have finally added support for auto scaling. Now, other than being platform managed, This service provides a lot of layer 7 capabilities. We immediately after launch, we added support for route-based, path-based routing, and site-based routing. So you could pack more and more sites on a single application gateway, and that gives you better returns. We always started with SSL termination support, and we added SSL policy to that. So now you not only get SSL termination, but you can create a policy and say, I only want these SSL ciphers or this SSL TLS protocol version. So that's a centralized place, and there has been multiple asks about enhancing over here in certificate management. I have some announcements on that I'll cover. Another key distinction for application gateway is that it works with any kind of backend pool. So as long as there is IP connectivity, as long as there is reachability, you can put it in app gateway's backend pool. So you're not limited to this within the same VNet or within the same cluster. You can add things in a peered VNet using private IP. You can add things which are outside VNet using its public IP or FQDN. You can even go outside Azure as if you use public IP. If you have a VPN on an express route connection to your on-premises, then application gateway can route to your servers on on-premises as well. So it provides you hybrid connectivity. Of course, a very common case is that people reach application gateway, the load balancer from internet. So we provide a public IP, of course, but we also can operate fully in a ILB mode, only an internal mode, so that only workloads from on-premises or within that VNet can reach it. So there is quite a lot of flexibility in the kind of servers you can put in application gateways backend pool. We recently added support for web app services, which have become first-class citizen. We have integrated more with platform components, web app services or cloud services. They can directly be added to the backend pool now. VMSS, of course, we have added long back. Application Gateway also provides very rich diagnostics. I will cover that in the new slides, next few slides on the new capabilities we have added on the diagnostics side as well. And we have added support for two very commonly asked features from the last time. We have added support for custom error pages, and we have also added support for connection draining. It is a little more than just connection draining. It is session draining as well. I'll cover that. Diagnostics enhancements. And one very common complaint was that the portal was, in a way, not able to keep up pace with the number of features we were launching. So we doubled down on that based on the feedback from customers. And now we are at full portal parity. All the features which are in production are also supported in portal. So we added support for SSL policy, error pages, connection draining, redirection, so on. So all of those capabilities are now supported at the gateway. Now, I'm talking about two new capabilities which we have launched on the generally available SKU. So this is called the standard SKU, and now we have added support for connection draining and custom error pages. Now, the way we do connection draining over here is that customer comes and says, not the user of the application comes and says that, hey, I want to remove this particular server for, let's say, a maintenance. So we start that draining process. Immediately, it stops receiving any new connection, right? And then once all the connections, all the in-flight connections have completed, and the threshold has been reached, then it actually removes it from the backend pool. Till that time, you will see that server as being in the draining mode. But the interesting fact over there is that if you are using cookie persistence and there are multiple connections which are still coming, the in-flight requests have completed, but there is a server, a user in the backend, in the front-end side, who has, let's say, loaded a page, and he is going to click on the next page. He still has the cookie, and he sends a new request. Then in that case, we will honor that. We will not accept any new connections, but if an old client comes with an existing persistence cookie, then we will honor it, and we will still send it to the backend pool which is being drained. So that is the only case where a new connection would be sent. And once the configurable timeout has been reached, at that point, it would stop sending any new connections or persistent connections and remove it from the backend pool. So the way you think about it is that you manage the connection draining threshold to approximately match your user's behavior. the session behavior of your user, and it would take care of the draining, both in-flight connections and persistent sessions. Now, we also added support for custom error pages. This has been very, very long-standing ask. It's a very straightforward feature. We have started with two definite use cases. We have a web application firewall, which at this point was showing a very generic page, which was not, you would not be able to customize it so far. So now with that, you can add a 403 specific error page, and it will give you, whenever the WAF throws an exception, then you could use your own, Contoso labeled or something which is your own corporation labeled error page. The second one is, again, continuing on the connection draining scenario about maintenance. So now we have added support for a maintenance page where you can say that if all servers in my backend pool are down for whatever reason, they could be down because of a misconfiguration, or you could have scheduled a complete maintenance. If all those pages are down, and I have nothing to route, app gateway has nothing to route to, then it shows a maintenance page by default. So instead of showing a broken page or a bad gateway error, you will see a customized maintenance page. Interesting thing is that this is customizable per listener. So you can have a global maintenance page. Remember that app gateway can support up to 20 sites and 40 if you open a support case with us. So you could have a global error page or maintenance page, and then customize it or refine it on a per listener basis. So we added support for that. In diagnostics, we have made quite a lot of enhancements. Access logs, audit logs, performance logs, all of these diagnostic logs were always present. We have added more metrics to the app gateway. So now you can see a lot more. You can see total number of connections, you can see total requests, failed requests, throughput, healthy or unhealthy backend servers, response status distribution. That was also a very commonly asked feature that, hey, tell me how many are returning 400 or 404 kind of errors versus how many are returning server errors on 5xx compared to 2xx. So now you get a full histogram of response status distribution. OMS log analytics was supported. We added support for Go Access. It's a very popular open source traffic viewing and monitoring library. So we have added components which take our own natively generated text and JSON files, convert them into a Go Access compatible format, and then you can see a rich visualization. I'll show a demo of that as well. We have added support for connection monitoring through the network watcher. So a lot of times when you are adding something to the backend pool and the health probe is not working, there was not a lot of information that why is it not working. So now you can configure a network watcher, and it knows that the source is application gateway, and the destination is the VM on the backend. So now you can directly see what is blocking that connectivity. So if there is an NSG in between, or if there is a UDR in between, or maybe a custom DNS is present and it's not able to resolve the FQDN, then now you can see exactly those error details. So it's very straightforward. It's integrated with the app gateway page, and you launch the connectivity monitor. You can configure it for continuous alerting as well. So it will keep on checking the connectivity, and if it experiences any failures, then it would alert as well. So this is also available now. Now, this is the new announcement which we are making on Application Gateway. So we have come up with a completely new SKU, which gives a lot of performance enhancements. It gives a lot of auto-scaling features, but it also bridges a lot of other requirements which customers were making of us. Specifically, you now have support for static WIP or reserved WIP. So this is the only WIP which is supported by default. So when you create an application gateway, you will choose a static WIP, and that WIP will not change on the lifetime of the gateway. Earlier, the DNS was guaranteed not to change, but if you stop the gateway and start it again, then the WIP could change. And this was a problem for customers who wanted to whitelist that IP with their partner firewalls or give a stable IP. So now you have with the new platform. We also implicitly have zonal resiliency presence. So in regions where Azure zones are present, you have the option to choose to deploy the application gateway into one or multiple zones. So you could choose that, hey, let's say in France Central, I can only want to deploy in zone 1. So that choice is there. Or you could say, I want to deploy the app gateway in all 3 zones. What it does is, it gives you a single IP which survives zone failures. Even if a zone goes down, that IP is still working. And the instances, the workers of the app gateway are distributed across these zones. So even if the zone goes down, the IP survives and the instances in other zones survive, and whatever instances were present in the zone which just went down are migrated to the newer zones. So now you get, with no reduction in your overall throughput, you get a zonal failover. I mean, you will have a reduced traffic till the instances migrate from a failed zone, but it survives. It offers you much better resiliency. Key Vault integration, ever since we launched SSL policy and certificate, everyone has asked for Key Vault integration. So this is a little early announcement. So we have Key Vault integration working in our what we call canary and test clusters. We are looking at releasing it very shortly. So it's very, very likely that it would come in October 2018. I'm very confident that it would land in that time. Now, this gives you, of course, a lot of benefits that you do not have to, the application developers do not have to touch the certificates. The certificate can lie on Key Vault, and even if it expires, we will keep on polling every configurable number of hours. By default, it is 8 hours. And we will poll it, and if there is a newer version available, we will pull it and reconfigure it so that if certificate renewal is taken care automatically. Now, the other big announcement on this same platform is auto-scaling and the performance enhancements. So let's start with the auto-scaling support. So by default, this new standard SKU supports auto-scaling. We operate in 2 different modes over here. You can choose to do auto-scaling, which is the default, or you could also choose to remain in the manual mode where you have a fixed LCU, fixed number of scale units. So we support both modes. Of course, the benefit is that the application gateway, no longer you have to configure it at the peak capacity. It will shrink and expand based on the traffic demands. And it also helps you reduce your operating cost. When you're not using the app gateway, the instance count would come down. And when you start using it again, instances count will go up and to help handle the traffic. So that is a big announcement for us. We have also, in the same platform, improved the performance by a lot. So just on RSA 2K keys, we are seeing 5 times improvement in the number of SSL terminations it can handle. So you only pay for the number of scale units you consume. So let's say that you consume a limit of 100 scale units, then the range you get now is somewhere around this, that you get up to 50,000 new SSL connections per second. And you get more than 250,000 HTTP requests per second, and up to 3 million persistent connections if you scale up all the way to 100 scale units. So that gives you an idea of the range which we can handle with this new SKU. Now, in addition to all the performance benefits, we have also worked very hard to bring down the provisioning and the configuration times. So now in the new SKU, it typically provisions in 5 to 6 minutes interval. So it's a 75% reduction from the current numbers. And configuration updates also have been brought down. If you call directly through API, it should complete in 30 seconds. If you call through portal or through SDKs, then it should complete within 40 seconds. And it covers most of the operations. So those are the 2 big enhancements. Let's take a look at this. Yeah, so just before starting the discussion, I was running our bench, and you can see that it was running around 52,838 connections, HTTPS connections per second, so new SSL connections. So let's take a look at this. Let's start one bench again. In the meanwhile, I'll just show you, while it is running, how do you create a new application gateway. So let's go to the portal. And let's choose application gateway, and let's just add a new one. So I'm myself a Microsoft employee, so it does not, all the features are rolled out to the public cloud first, public employees first, and it gets to the internal AD employees later. So that's why I need to change. Let's add. So let's say we call it test app gateway. And we can go to standard V2. Now, it gives me two models, autoscale being the default model, and manual is if you want to be in the fixed capacity model. So you have configurable choice. You can choose to be autoscale, and the minimum scale unit in case of autoscaling is the number of scales it would start with. So you can have 1 or even 0 to start with. And once you choose that, you can just choose to create a new resource group. Let's just call it and let's choose a region where we do have the Azure Zone capability available. And as soon as I choose France Central, you can see that I get a drop-down on which availability zones do I want to deploy this app gateway in. So I can choose 1, 2, or I can choose all of them. Let's just choose all of them. And the next step, it would ask me the basic questions, which it has asked all the time, of how to choose a VNet. So we can choose a VNet, an existing VNet, or create a new one. The interesting thing is that now you can see that when you go to the public IP, it automatically selects standard, which is the new IP, and it has made it zone redundant by default. So the IP is zone redundant by default. If I had chosen a single zone, then the SKU would still have been standard, but the availability zone would have been defaulted to that particular zone. So your IP has to reside, either it has to be zone redundant, or it has to reside in the same zone where your app gateway is going to be deployed. And you enter the same information and hit OK. And that's it, and you can just start creating one. Now, let's go back to the test we were running. So I just ran this test on the HTTPS workload, and it is showing me 50K SSL connections per second. So we can run it again. Now, what this test is doing is it's actually connecting to a Kubernetes cluster which has 50 to 100 instances, and all of them are sending data continuously, sending connections continuously to the application gateway, which I had created earlier. I can show the details of that gateway. This is this window. Yeah. So this is the app gateway which it is trying to reach, and let's just refresh it, and you can see that it is showing that it has cumulatively it is starting to ramp up again, and you can see that it has reached almost 3 million requests already. If I keep refreshing it, it will show you more and more requests arriving over there. And at the same time, you can see on the text bench that it is running 48,000, 51,000. So it is receiving, sometimes it is not receiving data from all of the instances. For example, here it just received from 19 instances. So you see a low number over there. But once it receives the data from all the 50 Kubernetes nodes, then you can see that it is running around 53,000 SSL connections per second at that point of time. I also wanted to show what would happen if we switched from SSL to just HTTP connections. Let's just let the test run. So in this particular test, it's not doing any keep alive. It is creating a new SSL connection. It is terminating that connection, and immediately it returns a very small amount of data and shuts it down. So in this particular use case, it is just showing the raw SSL connections per second data, right? If we run, once this test runs, we can also show you what happens if we switch to HTTP connections with Keep Alive turned on. You will see a much larger number because we support on a single scale unit around 550 connections per second. But on the HTTP with keep alive turned on, it is more than 2,500 requests per second. So I just need to change it from HTTPS to HTTP. And now it is going to target the same application gateway, but it is now going to do it with 100 different containers, and it is going to send HTTP requests to those instances. So it has just received information from 3, now 24. It should keep going up. So now it has ramped up at 31 containers. It has ramped up to around 75,000 requests per second. Let's give it a few seconds more. So now it is at 62, and it is doing around, at 90 containers, it is approaching 231, 245,000 requests per second. These are small requests, which is just sending a request, keeping the connection open, and then sending multiple HTTP requests over the same connection. So that is to give you an idea of the scale this new platform can handle. Now, apart from just the scale portion, this platform also does auto-scaling. So I ran a few tests just before starting that, so I'll just show this in the interest of time. But we started with around 50K requests. It started from 50 to 60K with 2 different instances, 2 scale units. And then as it sees a sustained load, it ramps up automatically. It goes from 60K to 90K. And you can see that it's a smooth step function. And it goes from 60 to 90, and then after we stop the load, it cools off for some time, and then it reduces the number of instances again. And you can see that load at that point turned down. So with that, what was the number for the slide deck? Thank you. Okay. Now, we have also heard from many customers requirement for supporting Kubernetes, the Azure Kubernetes service. So we have added support for application gateway, the newer application gateway, the V2, to be the default ingress controller. I mean, it's not a default. You have a choice to use the application gateway as ingress controller for AKS clusters as well. So essentially, at this point, what it does is when Kubernetes adds a new service, it sends an ingress request. And if it is annotated correctly that I want application gateway to be my ingress, then it uses our own pod, which is running a small service, an ingress controller, which translates those calls into application gateway API calls. And then it goes and programs the application gateway to be the ingress. So if I added a service and change the configuration, it would be listening to those changes in the AKS cluster, and it would automatically program application gateway so that it can route the traffic to the correct pods. So let's see that as well. So over here, I'm running a Kubernetes service. Let's just connect to that cluster first. So let's just quickly change our account and the credentials so that we can run it on this. So I'm switching just the account, and I'm going to change my ingress, the Kubernetes cluster where I'm pointing to. So I'm just starting a SSH tunnel so that I can actually get there. And let's just once it has started the tunnel, I can show you. Yeah. So this is the AKS cluster which we are connecting to. And at this point, you can see that it is running the very popular AKS guestbook service. And it is configured as an ingress. So guestbook has an ingress point, and it is annotated correctly to use Azure Application Gateway. So if you go to the application gateway for this particular AKS cluster, and let's go and see the backend pool. When you add this as an ingress point, it automatically programs this and creates a backend pool with the information about the node instances, the containers where it has to connect. And at this point, we should be able to route to this gateway. So using the application gateway, you can now route. This is the FQDN for the application gateway, and we are able to hit the guestbook application behind it. Now, now we can also go at this point, and let's see what happens if I go and try to delete that guestbook. So it has deleted the guestbook, and let's see the try to delete that once more. It sometimes takes a few seconds to come. That is not expected. It has deleted from here. And okay, let's go forward. It should have come forward, and the call should have come and deleted the actual ingress controller as well. Let's switch back to the presentation. Okay. Now, I have already covered the zone redundancy and static WIP, so in the interest of time, I'll keep going forward. Okay, now we also have added support for new features in the web application firewall. So the WAF now has two new announcements, but WAF itself is a nice add-on to the application gateway. So we have, once we started support for the public SSL policies and support for end-to-end SSL re-encryption, then the next logical step in the security umbrella was to add support for a web application firewall right at the gateway. We were doing SSL termination, and we can look at the packets deeply, and we can see if there are any malicious intent, any type of protocol violation or session hijack or LFI, RFI, and of course, the most common being SQL injection and cross-site scripting. So those two are, we have added support for 3.0 CRS, core rule set. That's very popular mod security OWASP rule set. So we support both 3.0 and 2.2.9 out of box. And we also allow customers to configure the rules. So they can run the WAF in two modes. They can run it in protection and detection mode. And they can, at that point, choose that. We see a lot of customers who start with a detection mode, take a look at what is the application traffic pattern, and then switch to prevention mode, and it actually starts blocking traffic. Now, the next step after that comes that what happens if I get a lot of false positives? So in that case, we have added support for rule selection. It has been available for quite some time now. You can go and enable or disable the rules which are not giving false positive for you. So you can disable the rules, and in that way, you can get around the problem of getting false positives. Now, that is going to remove that rule from the configuration of the website completely. So the next feedback we have gotten is that how do we add more configurability to reduce the false positives? So we have added support for two new features on the web application firewall. Again, these are in preview. We have added support for WAF configurability, where you can choose to have a global parameter inspection. So you can say that here is the maximum file size which I want to allow. So you can go from 1 MB all the way to 100 MB. If you are using large gateways, you can go to 500 MB. So now you can control how much of the file size you will allow. Now, if you're not using, and if you want to also restrict the size of the request itself, then you can use the request body size, and you can configure it from, again, 1 to 128 KB. Now, another important ask customers have is that what if I don't want to inspect the body at all, or I want to limit it to a certain number? So now you can turn off the request body evaluation completely. So if you're sending a post data which has a large amount of data coming into it, then you can use this field and turn the body evaluation completely. Now, another way of reducing false positive is, we have introduced, is exclusion lists. So on specific attributes of the request, you can completely exempt them from WAF evaluation. So for example, you can look at a header, a cookie, or a request attribute, a query string parameter, and completely exempt them from WAF evaluation. So you can say that, okay, I have an Active Directory application, right? Let's say a B2C application, which is using Active Directory for its authentication. And now Active Directory injects bearer tokens and various other cookies, which are long machine-generated tokens, and they always trip the WAF and provide, are a source of false positives for many of our customers. So with this feature, they will be able to opt those parameters into this exclusion, and WAF will not look at those features. So let's take a look at that as well. So what I've done is, I have a very simple application which is running behind two different web application firewalls. This is the first firewall, which is running in firewall is enabled, and it is running in prevention mode, and it has no exclusion parameter, right? And it is going to a backend pool, which is a very simple PHP application. So you can see that it is going to a particular backend pool, which has this 10.0.194. So this is the name of the VM. And I have a second firewall, which is also configured to hit the same backend VM. Let's go and take a look at that. So this is exactly identical rules, and it is hitting the same application behind. So it is also hitting 10 demo VM 10.0.1.4. And let's look at this particular VM. The only difference is that on this VM, I have already configured so basically, I have said that if there is any field in the incoming request which equals to comments, then exempt it from WAF evaluation, right? And you see that I have a very simple application which is running over here. And let's go to the configuration overview so that you can see that this is 178.161, and this is 178.161 index.php. And here is the second application which is running on the second WAF, which is 1362. Let's quickly confirm that. $1362. So here, if I try to give without, let's say, without the exclusion list, then I get a 403 denied error, because it is looking at that comments field and seeing that it has something objectionable. Whereas in the second WAF case, if I again try to do the same thing, then it should just go ahead. So it just added that, and it has added that particular field. So this is a mechanism. Again, this is a simple application. You are showing it with a comment wall. But if it was a B2C application, then you would be able to go over here in the web application firewall. And we provide a lot of primitives over here. So you can say that if I have a request header, and if it starts with or ends with, or if it contains a particular field, or if you want to add any request header, all of the request header, then you can do that as well. So if you do that, it will not have a selector, but it will exempt all the headers. But if you wanted to do only for a header which contains, let's say, some cookie, right? So then it will not evaluate any request headers which have cookies there, or let's say it was a token, right? So it will not evaluate anything. You just hit save, and now the WAF is configured for that. So that is another important feature which we have launched on the web application firewall. Now, with the WAF standard v2, which was the newer platform, WAF has also gotten into the newer platform of WAF v2, and it gives you all the capabilities except the auto-scaling for now. Auto-scaling is going to come very shortly. So you can make it will give you a static IP, and it can also give you zone redundancy. So we'll be adding into the same SKU support for auto-scaling shortly. And you also get performance benefits, which comes with the new SKU. So that is all I had for application gateway. I'll invite Daniel again for the remaining portions.
Awesome. Thanks a bit. All right, I still got to do this clicky thing. So that was basically how you use application gateway in a region to build sort of your regional resiliency story. Look at WAF, look at sort of the overall sort of architecture there. In particular, how do you take that to, sort of a stable expectation with WAF, and how do you handle things like zonal resiliency? Now we're going to switch gears a little bit, sort of taking ourselves out of the data center to more of a global scope. So now you have regions across the world, and you need to be able to route traffic across those regions, and you need to be thinking about how are your users getting to those data centers themselves, and how do we kind of think about that problem space. So from a general global application perspective, you really want to be thinking about resiliency. In particular, if you're thinking about mission-critical apps, how do you handle the kind of scale-out and things at that global scale? How do you handle things like unforeseen events and things like that that might take out some portion of infrastructure? How do you then translate that while you're maintaining that high availability into a high-performance service, so your users actually get the best performance they can? They go to the right data center, they get the right, the best-of-breed performance from there. And then how do you get global optics so that you're not just looking at a region, but you're looking across the globe and understanding where all your users coming into the network, where are they really looking, where are they routing to, and how do your individual regions look over time? So our first solution for that is Azure Traffic Manager. It is DNS-based load balancer. It provides you that sort of upfront, easy to provision, ability to do fast routing that basically gives each user is on a map. That user gets routed to the closest data center. It monitors for availability, and when that goes down, it will fail you over. It also gives you that same optics view of analytics to be able to see where users are coming in and really understand kind of your traffic at that global scale. That one. Some new elements from that, as I talked about before, was subnet routing. There's a great tool called Traffic View that lets you see kind of visually and understand where your traffic's coming from across the globe. And it gives you the ability to look at logs across all of that. The next thing that I'm going to talk about is really about front door service. We're focusing a bit on this because it's new. We just launched into preview, and we're talking really about how do you kind of take your options for using a DNS-based load balancer versus an HTTP-based load balancer. The difference really is on the path versus more of a control plane. DNS is going to steer your traffic, but you're going to still hit those IPs. When you have failover from a region, your user sees that because the IP changes. If using an HTTP-based load balancer, that doesn't happen. Your users go to a consistent IP address, and then the failover happens behind the scenes, where everything gets routed behind that, as well as there's some benefits I'll talk about in a second. But really with front door, you get the benefits of HTTPS termination, at scale. It's a multi-tenant service, so you can scale out just as you can with App Gateway, but you can at a global scale instead, scale out your traffic. And you get that fast failover in terms of load balancing, similar to if you were going to use a traffic manager, but then you get it on the path, and I'll talk about how that works. One of the better benefits that you get with Front Door is you get application acceleration. I'll talk about it in a second, but we are deployed at the edge of Microsoft's network. It's not a regional service. It's not deployed even in our data centers, except for in some cases where we're very close to an edge site. But in general, it's there to get really close to your users. If you have users, say, in Manila, how do we get our Front Door service as close to them as possible and reduce the overhead of communication? And the last is looking at the sort of a similar picture of global insights, but really trying to understand the mechanics of your traffic and how is it flowing sort of end-to-end, reaching basically application gateway and your other services in your region. So Front Door is not a new service. It's been around for the last 5 years. It's been something that we've built as best of breed for Microsoft itself. So if you go to anything on here, Exchange Online, SharePoint Online, Bing, MSN, OneDrive, Teams was built natively on it. All our stuff internally, basically, if they're focused around high availability and performance, they've used Front Door as that platform to be able to provide that global veneer for routing and for acceleration for their services. The reason we're bringing it out now is that same demand we hear over and over again from customers of Azure of, I'm building global scale websites. How do I really accelerate? How do I really get kind of best of breed for my service? How does this work? I'm pretty sure we've dragged this slide around for the last 5 years. But the first benefit of Front Door is traditional application acceleration, which is if you're establishing a TCP connection, especially if you're using SSL, there's going to be a lot of negotiation overhead that goes between the client and your server to set up that connection. If you're doing that over a long distance, you have to traverse all those round trips back and forth to the origin or to your service to be able to start that connection up. With a HTTP proxy, all of that goes to the proxy itself. So Front Door sits there, hosts your global domain, and all of that communication overhead happens there. We then keep a connection open to the back end that basically accelerates that traffic. So you make, over a shorter distance, more round trips, and then those longer haul connections, say if you're going from your users in New York and your data's in US West, you don't have to make all those long round trips over that long haul. Instead, we keep a hot connection there. There's a bunch in terms of what is the overall impact. In terms of TCP congestion control, there's a huge impact if you lose a byte, whereas we are able to basically handle that communication ourselves. Oh, this is a click-through one. All right. From a basic perspective, if you're deployed, say, in a single data center on our network, or even in multiple data centers on our network, your application is distributed across multiple points. The place where Front Door is deployed is on these network edge sites outside of those data centers. And the unique thing to us versus going to, say, a third-party CDN or something like that that's going to provide you a dynamic site acceleration service is that in addition to owning the data centers and really being able to kind of build this hub-and-spoke topology, is that we own a global network. And so once you've hit our edge site, once you've hit Front Door, you're going to go over our private network, which means we own it end-to-end, which means we're able to do a lot more in terms of acceleration, cost management, and things like that, because it is our accountability to keep that network healthy and ready for your traffic. The additional benefit of Front Door is that if your users, say, in Bangladesh, they're going to hit the closest edge site to them. Our service is an Anycast-based service, which means that it drags traffic into the closest point on our network possible. The benefit there is that instead of traversing the open internet again, we're trying to get it onto our network that we have built for all of these giant enterprise applications as fast as possible, and then you get to ride our network across the planet. So that same thing happens for other users anywhere they are, and they can still reach your services across our network. How does sort of the WAN acceleration work is a question we get very frequently. We use this common analogy, which is if you're relying on the client's congestion control mechanism, they're dealing with whatever they're dealing with on their last mile. And so if they're on a mobile network or on, say, a 3G network, congestion controls are going to be very encumbered by just the congestion on that last mile that they're dealing with. And so our analogy there is basically if you're trying to take a taxi from, say, Amsterdam to Manila, you're using that kind of a mechanism going across the open internet, even going across our own backbone without it being accelerated, because you're going to be basically dependent on whatever the congestion control impacting that client is, and you don't have a lot of control over that. The difference when you move to something like an application delivery network like Frontdoor is that you get to use and split the problem into two pieces. The shorter distance, you have to deal with those sorts of more complex congestion control issues that the client, which we can't necessarily fix. It might be a device issue, might be their network, might be something in the way, might be everyone's watching Monday Night Football and therefore they're congesting just the general internet. But once you've entered our network as fast as possible, we basically own that connection on the back end, and we can do unique things across the backbone to be able to really optimize how efficiently and how much throughput we can get across that long-haul link. And so tying those things together basically gives you that optimization with our network to be able to look at speed up for your application. I'm not going to go into a lot of detail around this. It was something that if you watched Albert Greenberg's talk earlier on, he talked about a bit. But in general, Frontdoor is built with enterprise-grade resiliency in mind. Everything has a failover. We use Anycast because it's immediately consistent. We have a high-speed, real-time failover for your origins because it's very quickly consistent. We have failover for any of the dependencies in the way to be able to be more consistent over that time. And this was built to support Office and things that have a really tight SLA that we communicate out to customers. And so this is basically taking that same architecture of high resiliency and giving it to you for your applications. I'm not going to go into each feature because I'm going to go and do some demos on how this works. But in general, we're a fairly mature 5-year-old service. We have a good set of features that are really focused around how do you really orchestrate this thing at the edge? How do you really orchestrate your global routing? How do you do things like rate limiting and things that are really there? You want to stop it as far out as possible. And it works in conjunction with application gateway and things in the data center to be able to really build that end-to-end, to really be able to host components in both places. There are some places where there's overlap, say both do SSL offload, but there's reasons for that. Some things you need to do just application gateway in the data center, say you have a private application, say you have different types of compliance needs and things like that. Sometimes you need to do stuff at a global scale if you're dealing with large regional scale issues because it'll isolate those better than in the region. So what I'm going to demo is basically how do you build sort of a basic scale of application with Frontdoor. This is let's call it a toy picture of a basic architecture. If you've seen many of these talks that talk about blueprints, we tend to orient them when it comes to Frontdoor more vertically than horizontally because it's not an entry point to a data center, it's an entry point globally from all of your users. And so it's really about how do you take something that's coming in everywhere and funnel it down to the right places. And so what we're going to talk about here is how do you set up things like HTTPS, how do you set up path-based load balancing, how do you set up things like DDoS, and how do you really kind of think about the problem space. So with that, I'm going to predict that that is the right number, and it is. So to start off, basically what we have is a couple of regional websites. So we have one called AFD Demo, poignantly, deployed in the central US region. It looks like this. I have one that's deployed in UK South. It looks like this and says UK South. And they both basically give you kind of a picture of your regional deployment of a service. I'm not using App Gateway just because we see a lot of folks coming in with web apps, and we wanted to kind of do something more simple so it's easier to draw the picture. But pretend these are basically your application gateways or whatever your origin is that really fronts in your VNet or fronts your application service. So in order to set up front door, it's really easy. Usually I don't show how to search in the portal because everyone knows how to do that. But because we're new, I'll show you that it does show up. It's easy to access. And setting up front door is, we try to make it easy in a way that you can kind of understand as a proxy service. Similar to the way the App Gateway really looks at front ends and back ends, we wanted to replicate the same kind of logic so you understand that these things are, it's a load balancer at the end of the day. It has a bunch of benefits, but you have a front end, which is your global domain, and your back ends, which are basically, instead of being your VMs or your dips, are your regional endpoints for your services. So I'm not going to create it in my bug bash service, but basically starting to create it, you basically get this layout. And we're trying to find ways where introducing yourselves to a service like this that has a lot of features and is complex, similar to App Gateway, is that you get this ability to look at sort of more of a paced map to start. It gets you really quick to do it, and then we understand that everyone's going to dive right into using the command line and ARM APIs. So it supports basically end-to-end, either getting started with the portal or how do you sort of automate things with the APIs. To start, we create, similar if you're creating a traffic manager or something like that, you're creating your global CNAME. This is basically a test domain or a way that you kind of set things up. For example, I'm going to create something, what is this, breakout, BRK3301. It's probably close. You can set up things like session affinity if you want us to keep sticky connections back to individual origins or individual regions. That helps in terms of cases of failover if you have multiple, say, endpoints in a region, so that your users get less, let's say, thrash when there's failover and stuff like that. Setting this up is fairly easy. You basically then come back and say, all right, I'm going to set up my backends. You give it a name so it's easy to understand. Say this is my prod pool. And I can't have an underscore. And what we do is we give you an easy way, similar to other services like this, to be able to discover your origins. In addition here, we include the ability to discover a lot of your app service endpoints, since we have a lot of folks that really just want to compose those quickly. For this purpose, I'm going to basically show you through AFD demos. We have them in most regions, but I'm going to pick basically central US. If you have a custom domain set up today at your origin, say you're already using app service behind something like Traffic Manager or some other load balancer, you can change the host header here to be able to accept sending it back. You can even leave this blank, and it will just pass through the one that's coming in. And so you can make it transparent if you don't want to, say, interrupt your current service while you're setting things up. A lot of folks with ACLs don't want to set up, don't want to change whatever their app service looks like to be able to try it out. And so this is a way to make it so that you don't have to make any changes. It gives you access to port, either for HTTP and HTTPS. And then we offer a couple of things called priority routing and weighted routing. Priority routing gives you the ability to do oh man, this is like cutting out. It gives you the ability to do a level of failover for your application. So you can, say, have first priority and second priority origins or backends. And so that gives you the ability to say, only until all of the first priority things are down do I want to route to the second. And for a lot of BCDR architectures, we see that kind of primary, secondary architecture set up. It's a lot of times done for cost reasons, where you want to have kind of your primary pool, but you want to fail over to something that's auto-scalable at sort of a secondary priority. And then weighting is basically a even allocation of traffic. If you leave them all the same, they get allocated all the same. But basically, it's a way to, if you want to steer traffic, weight it basically towards a endpoint or another. This is good for things like if you're spinning up a new region or something like that. And then we allow you to introduce it enabled or disabled. If you have a ops team next to your DevOps team who's really setting up these services, a lot of times the best practice is to introduce the backends to a live service in a disabled format and then enable them later. So you can test them one by one instead of doing something like a big batch and watching the traffic, distribute again. Adding this is pretty easy. You can add a set of health probes. I'm going to steal a quick URL. But basically similar to any of these other load balancers, you set up an endpoint that you can hit, that you can route to. We're going to send traffic to that endpoint. The difference between front door setting traffic to that probe endpoint versus another load balancer is we're doing it from the edge side. We're doing it on the exact path that traffic's going to take when a user requests something from front door and we go and proxy it to the back end. It'll be a consistent path. And so we're monitoring that end to end, not just is your back end up, is your app gateway up, but we're going to monitor the path as well. And so if there's any degradation in performance, we also can shift traffic. You can set up basically whether you want to do that in HTTP, HTTPS, as well as the interval frequency. And then from a load balancing perspective, we work in more of a windowed format because we understand it's a global routing topology, and so we understand that there are changes that happen. Not everything is consistent across all time. And so this gives you the ability to have a different window. So in this example, we have a sample size of 4, which means that we have to see 4 failures, or at least 2 failures across the 4, so 50% failure rate to be able to handle that. And then because there could be variability, and you don't want it to move very quickly, we give you basically the ability to set the sensitivity in milliseconds. So once you go through this process and create your backend, you'll basically come through and create a routing rule. Routing rule, and I'm going to skip through this really quickly, and we'll talk about it in a second. It basically gives you the ability to map these front-end hosts to your back-end pool. So you want to have all of your front ends go to your back end. It gives you the ability to do this on different protocols. If you want it to go to a different set of backends based on HTTP versus HTTPS, and if you want to do it on certain paths. So if you have microservices, say you want the /search path to go to this microservice versus the root, or versus something like /statics, you want to go to storage, you can set that all up here to different backends. Taking one that I've created earlier for ease and speed, basically you can do this, and as you see here, we've also set this up with a custom domain. You can bring your own cert, or you can have us manage the cert for you, but you can tie your custom domain to it and tie kind of your microservice architecture through these individual routing rules. And as you see, once we've sort of deployed that, despite the fact we've set this up with 2 backends, one in, 3 backends, 4 backends, Central US and UK South and Korea, it's going to route to the closest one, which is Central US to us. That's because we're running those health probes all the time. Same thing with the global domain. It has the same behavior. It basically looks the same, resolves the same IP, everything like that. What you can also set up, which I haven't done here, is you can set up a set of WAF rules. I'm going to sort of talk through this a little quickly, but you can set up a set of WAF rules that give you, say, geo-restrictions. So if you have countries you don't want to be able to access your app, you can do that with the service. As you see, on the same profile, we've blocked traffic from everything except for the United States. So in Japan it's blocked, Netherlands blocked, Russia's blocked, Singapore, I guess we've unblocked as well, and the United States we've allowed traffic from as well. And so that gives you the ability to really think about some of those WAF scenarios. A example of how to handle this is that, so for one of the things this gives benefit to is if you're doing something in a more development-centered way, it gives you a sense of safety if you've replicated your origins. For example, something that you probably don't want to do on a daily basis is take your app service or your app that's running in Central US and just materially stop a prod service. But you can, and with Front Door, because we know where your other origins are, we know what the fastest next one is, despite the fact having the ability to go to, I guess Canada's disabled, but UK, South, or Korea, is that over that same time frame, we will fail your traffic over. takes a second because I've set it up for that long time window. You can create your health probe frequency at whatever sort of more aggressive posture you want to make that much faster. But basically, you can set it to fail over to your other origin, which it seems like it doesn't want to do right now. There we go. That's cached. All right, so in a second, it will fail over to UK South, and you'll be able to basically see that. And you can set those frequencies and windows of how fast you want to send health probes to how fast you want to have that failover happen. And so what that will let you do is basically set up your endpoints around that. Another thing that this happened to demo here while I was doing that is we've also set it up for rate limiting. And so right now it's set up to 10 requests from a single IP address. We'll cause it to block traffic, basically so that you can start to set up those rate limits and set up policies more around fairness through the service. And very quickly, little bit around what you can get out of it, because we understand that if you're operating this at scale, you want to have details and scale out of your overall service. We have a lot of telemetry and metrics that you can view, and we also provide you per request logs for all the traffic that's coming through the platform. And so what this does give you the access to is if you want to look at, say, all of the global traffic coming from to your application, you can do that here, and you can do it from both just the traffic that's going through, as well as if you want to look at block traffic, you can look at what's the reason why our protection suite blocked a particular request, especially for auditing purposes. That's valuable. So. I'm not going to get into URL rewrites, but it also supports URL rewrites. For example, like if you have something in the media folder, you can have our service basically rewrite the path so that you can map basically front door onto whatever your origin structure or whatever your backend structure that you have today. So with that, since we're low on time, I'm going to switch back to the deck. And so this is a real brief overview of the application protection features in front door. A lot of these are things that you want to think about at a global scale. One of the benefits of Anycast is it keeps dragging that client into that same location, and so you get a more consistent decision on a per client basis through front door that way. So putting it together, we want to give some guidance on how do you really build these applications at scale. How do we recommend these architectures so that you can kind of think about if you're building, like, say, a global web application like this, how do you really construct that out of the components we've provided? Front door's in preview, so obviously the caveat is don't use it until it's GA for your production workloads. But as it goes GA, we recommend you basically get the benefits of front door in terms of performance boost and scale out. As well as using it with Application Gateway if you want to do the same thing in the region, be zonally redundant, things like that. If you have more regulatory or geo-restricted applications, things that need to be, say, geo-isolated, front door's Anycast, so we're going to drag it to the potentially out of a country if that's the closest place for that user. If you really want to keep it isolated, especially if you have different endpoints, you may want to use something like Traffic Manager, which provides some capabilities around that, as well as front door has a reduced subset of compliance requirements because we're running an edge site, not running in a protected data center that's likely bomb-proof in some cases. So depending on what your compliance needs are, there are places where you'd still want to just use regional services. And then if you have hybrid or non-HTTP applications, using Traffic Manager often makes sense. If you're routing to something on-prem and you have a direct connection from your office to that location, you may hairpin through our edge routing to that endpoint. So we recommend, for at least right now, using Traffic Manager to do that. So that is it for our time. We're going to be around with my 45 seconds left to take questions. We've got some front door stickers and things like that. But thank you for your time, and I hope we help you kind of understand what is sort of the regional and global landscape look like when it comes to sort of these global and large-scale, highly available web applications. So thanks a lot. And we love